Man, it feels like we're in the middle of a silicon gold rush, right? I mean, every single week there's a new AI chip hitting the scene, and they all promise to be faster, smarter, and just more powerful than the last one. This whole hardware revolution is all being fueled by generative AI, and it's created this dizzying landscape of GPUs, NPUs, and a bunch of other acronyms. So how in the world do you make sense of it all?
And that brings us to the big question, the one on everyone's mind. From the CEOs of huge tech companies planning their next giant data center, all the way down to, maybe you, just wondering what your next laptop should be. We all want to know, if you're building for the future, what is the single best chip to bet on? Well, here's the answer, and it might actually surprise you. It's not about finding one winner to rule them all. The most important thing to get is that this isn't a single race. It's more like a decathlon. See, different chips are being designed for very different events. So the real question isn't what's best, it's what's it best for?
So in this explainer, we're going to break it all down. First, we'll get into why this revolution is happening right now. Then we'll take a trip into the cloud to see the heavyweight chips that are powering the absolute giants of AI. After that, we'll bring it right back down to earth, to the hardware you can have sitting on your own desk. We'll meet the new kid on the block, the NPU, and finally, we'll see how this all comes together in the new AI PC. So why the sudden explosion? Well, to put it simply, when powerful generative AI like large language models showed up, they created this massive, totally unprecedented demand for computation. You see, traditional CPUs, the brains of our computers for decades, they're great at doing tasks one after the other, in a sequence. But AI needs to do millions of simple calculations all at once, in parallel. It was a totally new class of problem that required a new class of tools. All right, let's start at the very heart of the AI revolution, those massive, humming data centers where models like ChatGPT are literally born. These places are the engines of generative AI, and they demand an amount of power that is just almost unimaginable. In the enterprise space, it is a battle of titans. On one side, you've got NVIDIA's B200. It's the king of raw computational power, and it's backed up by its completely dominant CUDA software ecosystem. But on the other side, AMD's MI325X is making a serious play by focusing on a different strength, a colossal 256 gigabytes of VRAM. Now, think of VRAM, or video memory, as the chip's dedicated workspace. The more you have, the larger the AI model you can work with at one time. And that makes the MI325X perfect for serving up the absolutely gigantic models that companies like Meta are deploying. And just to give you a sense of the scale we're talking about here, take a look at this number. That's the starting price for a single server unit. And these things aren't used alone, they're packed into massive racks. We're talking about an investment of millions upon millions of dollars just to get the infrastructure needed to train a cutting-edge AI model. It's wild. But it's not just a two-horse race, not by a long shot. This shows how specialized players are carving out really critical niches. You've got Groq, who is laser-focused on just one thing, ultra-fast real-time chat. Then there's Cerebras, creating these massive wafer-scale chips for super complex scientific research. And of course, the cloud providers themselves, like AWS and Google, are building their own custom silicon, like Inference and TPUs, to offer the most efficient or cost-effective performance inside their own ecosystem. Okay, let's step out of those massive air-conditioned data centers for a minute and bring it back home. How can you get a slice of this incredible power on your own machine? Let's talk about the super exciting world of running AI locally. So, for the enthusiast who wants that top-tier, no-compromises performance, NVIDIA's upcoming RTX 5090 is the beast to look for, supposedly with 32 gigabytes of VRAM. But for the best bang for your buck, a used RTX 3090 with its 24 gigs of VRAM is still a fantastic choice. Now, Apple users have a really unique advantage with their unified memory, which lets them experiment with massive models right out of the box. And on the PC laptop side, AMD's Ryzen AI series is really focusing on its powerful NPU to handle all those everyday AI tasks super efficiently without killing your battery. Okay, so if you're building a rig for local AI, what should you prioritize? Number one, above everything else, is VRAM. The more you have, the larger and more sophisticated the models you can run. The GPU itself is absolutely paramount for that parallel processing power we talked about earlier. But the software matters too. NVIDIA's CUDA is the undisputed standard, which means most things just work. And hey, don't forget the rest of your system. You still need plenty of regular system RAM and a fast SSD to feed all that data to your hungry GPU. Now, I've mentioned this NPU thing a few times. This is the newest piece of the puzzle, and it's arguably the most important one for the future of our personal computers. So let's take a closer look and figure out what it really is. An NPU, or Neural Processing Unit, is a specialist. That's the best way to think about it. It's been designed from the ground up to do one thing, and do it exceptionally well: the very specific type of math that powers neural networks. By stripping out all the other general-purpose junk, it can perform these tasks using an incredibly tiny amount of energy. So think of your GPU as a high-power workhorse. It's built for the heavy lifting, training AI models, high-end gaming, generating video. It's incredibly powerful, but boy, is it thirsty for electricity. The NPU, on the other hand, is the ultra-efficient specialist. It just sips power, which makes it absolutely perfect for tasks that are always running in the background, like blurring your background on a video call or providing live captions, without completely draining your laptop's battery. And believe me, the race to build the most powerful NPU is seriously heating up. We measure their performance in TOPS, which stands for trillion operations per second. I mean, that's just a mind-boggling number. As you can see from this chart, Qualcomm is currently leading the pack with its Snapdragon X2 Elite, pushing up to 85 TOPS. But Intel and Apple are right there in the mix, and you can bet these numbers are only going to climb higher and higher. So we've got the CPU, we've got the GPU, and now we have the NPU. How do all these pieces fit together? Well, this is the core idea behind what the entire industry is starting to call the AI PC. And it's not about one chip replacing another, it's all about teamwork. The best way to think of it is like a team. Your CPU is the director, right? It manages the whole show, handles all the general purpose tasks. The NPU is the specialist, efficiently handling all those constant, always-on AI features in the background. And then when you need to do some real heavy lifting, like generating an image or playing a graphically intense game, the powerhouse GPU kicks into high gear. And that is the absolute key takeaway here, that they are not competitors, but collaborators. It's a system of smart delegation. Each processor tackles the workload it was specifically designed for, and what that leads to is a computer that's not just faster, but fundamentally more efficient and a whole lot more intelligent. And all of this leaves us with a really fascinating question for the future. For decades, we've measured our computers by their speed, gigahertz and gigabytes. But as these specialized AI processors become more and more integrated into everything we do, are we going to start to measure our devices by a completely new metric? Not just how fast they are, but how smart they are.
Hey, if you enjoyed this breakdown of some pretty complex tech, do us a favor and be sure to like and subscribe for more explainers just like this one. Thanks for watching.